Hello, my name is Gerardo Jesus Mota Alguin and welcome to the class. In this class, we are going to talk about Azure 900T0X, the first model. It's about cloud concepts. About this course provides foundational level knowledge on cloud concepts, core Azure services, security, privacy, compliance, and trust, and Azure pricing and support. The audience for this course is just beginning to learn about cloud computing and how Microsoft Azure provides that service. There are two versions of this course, a 1 day version and a 2 day version. The content for both courses aligned to the Azure 900 exam objective domain. There are no prerequisites for the course, but students with an IT background will find the concepts easier to understand. In the first model, we are talking about outline. You will learn the following concepts: cloud models, cloud benefits and considerations, and cloud services. In the part of cloud models, you can see public, private, and a hybrid cloud choosing the best for you. In cloud benefits and considerations, we are talking about benefits of the cloud and cloud considerations, and the cloud services, we are talking about sharing responsibility. We are talking about cloud models, and we can identify different cloud models. And we are talking about objective domain. Define cloud computing, describe public cloud, describe private cloud, describe hybrid cloud, compare and contrast the three different cloud models. Next, we will see a description of what is Azure and how does Azure work. So, Microsoft Azure is a private and public cloud platform. You may be familiar with the Azure services the developers and IT professionals use to build, deploy, and manage the applications. But how does it work? Well, Azure uses a technology known as virtualization. Virtualization separates the tight coupling between a computer's CPU and its operating system using an abstraction layer called a hypervisor. The hypervisor emulates all the functions of a real computer and its CPU in a virtual machine. It can run multiple virtual machines at the same time, and each virtual machine can run any compatible operating system such as Windows or Linux. Azure takes this virtualization technology and repeats it on a massive scale in Microsoft data centers through the world. Each data center has many racks filled with servers. Each server includes a hypervisor to run multiple virtual machines. A network switch provides connectivity to the servers. One server in each rack runs a special piece of software called a fabric controller. Each fabric controller is connected to another special piece of software known as the orchestrator. The orchestrator is responsible for managing everything happens in Azure, including responding to user requests. Users make requests using the orchestrator's web API. The web API can be called by many tools, including the user interface of the Azure portal when a user makes a request to create a virtual machine. The orchestrator packages everything that you need, picks the best server rack, then sends the packages and requests to the Fabric controller. Once the Fabric controller has created the virtual machine, the user can connect to it. Azure makes it easy for developers and IT professionals to be agile when they build, deploy, and manage their applications and services. But this agility can have unintended consequences. If unauthorized resources are created, or if resources are left running after they are no longer needed, the solution to this problem is to use Azure's resource access management tools. After this, now it's more clear. What is cloud computing? Cloud computing is the delivery of computing services over the internet, enabling faster innovation, flexible resources, and economies of scale. For example, we have compute, networking, storage, and analytics. Cloud computing is a model for enabling on-demand access to a shared pool of configurable computing resources, servers, network, storage, applications, and services. Ubiquitous, convenient on-demand network access, rapidly provisioned and released with minimal management effort or service provider interaction. Now we are going to see what are public, private, and hybrid clouds and his benefits. For example, the first one, public cloud. Public cloud, uh, we can see the benefits. Owned by cloud services or a hosting provider, provides resources and services to multiple organizations and users, accessed via secure network connection, like typically over the internet. When we using a private cloud, the organizations create a cloud environment in their data center. Organization is responsible for operating the services they provide. Doesn't provide access to users outside of the organization. In the private cloud, the organization is responsible for operating the services they provide. Self-service access to compute resources provided to users within the organization. Let's see what it is. Hybrid cloud model. Hybrid cloud models have the following characteristics. Resource location. Specific resources run or are used in a public cloud and others run or are used in a private cloud. Cost and efficiency. Hybrid cloud models allow an organization to leverage some of the benefits of cost, efficiency, and scale that are available with a public cloud model. We have control. Organizations retain management control in private clouds. And we have skills. Technical skills are still required to maintain the private cloud and ensure both cloud models can operate together. Summarizing, we can see a comparison of the three models. In the first model, public cloud, no capital expenditures to scale up. The applications in a public cloud can be quickly provisioned and deprovisioned, and the organizations pay only for what they use. In the private cloud, the hardware must be purchased for startup and maintenance. The benefits to use a private cloud is that the organizations have complete control over resources and security, and the organizations are responsible for hardware maintenance and updates. In the hybrid cloud provides the most flexibility. The organizations in the hybrid cloud determine where to run their applications and control security, compliance, or legal requirements. We have benefits and considerations when we use cloud computing. High availability, scalability, global reach, agility. disaster recovery, fault tolerance, elasticity, customer latency capabilities, predictive cost considerations, and security. So, what is Microsoft Azure? To put it simply, it's a collection of online services that organizations can use to build, host, and deliver applications. The best part is that you don't need to have your own data center or even any servers because Azure runs in Microsoft data centers around the world which your users can access over the internet. Not only does this approach save you the trouble of having to build and maintain your own on-premises IT infrastructure, but it can also save you money because you only have to pay for what you use and you can scale your Azure resources up and down as needed. For most applications, you need three core elements: compute, storage, and networking. Let's start with computing. Azure's early days, Microsoft offered only one type of compute service: virtual machines, or VMs. For short, these are machines that run either Windows or Linux. If you currently have an application running on a Windows or Linux server, try why to migrate it to Azure is to do what's called a lift and shift migrations. That is, you simply lift the application from your on-premises server and shift it to a virtual server in the cloud. As your VM are known infrastructure as a service because they're traditional IT infrastructure components that are offered as a service. Later, Microsoft came out with what known as a platform as a service offering called Azure App Service. This platform lets you host web and mobile applications without having to worry about the underlying infrastructure. Have doing a minor amount of configurations, you can just upload your code to a service instead, and Azure take care of the details. In most cases, this is a better solution than using virtual machines, but there are times when it makes more sense to use virtual machines. For example, if you have an application that's not a web or mobile app, then you can use app service. So you have to use virtual machines these days. The host's compute technology is containers. These are self-contained software environments. For example, a container might include a complete application plus all of the third-party packages it needs. Containers are somewhat like virtual machines, except they don't include the operating system. This makes it easy to deploy them, very light compared to virtual machines. In fact, containers run on virtual machines. Microsoft provides a variety of ways to run containers. Simplest way is to Azure Containers Instance. This service lets you run container using a single command. If you have a more complex application that involves multiple in containers, then you'll probably want to use Azure Kubernetes service, what known as a container. It makes it easy to deploy and manage multi-container applications. Before we move on, I should mention on one more compute service. It's called Azure Functions, and it's Microsoft's main serverless offering. Azure Functions is kind of like Azure App Service, except that it executes individual functions rather than entire applications, and you only pay for it when it gets used. When you provision an app service instance, it runs until you shut it down. It's possible to configure Azure Functions in the same way. It's usually better to use the consumption plan, which means that it only uses resources when a function is running. So you only pay when a function is running, okay? Resuming the above, we are talking about the considerations and the benefits of cloud computing. We want to talk about capital expenditure and operational expenditure. In the capital expenditure, we have spend on physical infrastructure upfront, deduct the expense from your tax bill, and hide upfront cost. In the case of operational expenditure, spend on services or products as needed, get billed immediately, deduct expense from your tax bill in the same year, and no upfront cost pay as you use. We need to talk about consumption-based model. This consumption-based model brings with it many benefits, including no upfront costs, no need to purchase and manage costly infrastructure that they may or may not use to its fullest. Other thing is the ability to pay for additional resources when they are needed, and the ability to stop paying for resources that are no longer needed. We also need to know the different cloud services. Services like infrastructure as a service, platform as a service, software as a service. Identify a service type based on a use case, describe the shared responsibility model, and describe serverless computing. We need to talk about this. We have to talk about infrastructure as a service, most basic cloud computing service category. Boil pay as you go, IT infrastructure by renting servers, virtual machines, storage, networks, and operating systems from a cloud provider. Instant computing infrastructure provisioned and managed over the internet. Also, we can talk about platform as a service. Provides environment for building, testing, and deploying software applications. Helps create applications quickly without focusing on managing underlying infrastructure. And finally, we can talk about software as a service. Common use scenarios, examples of Microsoft software as a service include Microsoft Office 365, Skype, and Microsoft Dynamics Online. The next slide contains only some of the cloud service comparison discussion points, as you can see. To finish this content, I want to talk about what is serverless computing. Serverless computing enables developers to build applications faster by eliminating the need for them to manage infrastructure. With serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. In understanding the definition of serverless computing, it's important to note that servers are still running the code. The serverless name comes from the fact that the tasks associated with infrastructure provisioning and management are invisible to the developer. This approach enables developers to increase their focus on the business logic and deliver more value to the core of the business. Serverless computing helps teams increase their productivity and bring products to market faster, and it allows organizations to better optimize resources and stay focused on innovation. Well, this is all for now, and I thank you for your attention.